In this problem, we are given a circuit diagram right here, and then we're asked to find the power absorbed or delivered by the 2 amp current source in this circuit. Our 2 amp current source is this part in the middle right here. We are going to be using the node voltage method. I provided an example that's linked in the notes that are below in a Google Docs, and the steps that we would do for the particular example here. We only have one unknown voltage here. We can see that we have our voltage source right here to the left. We have our V1, which is unknown, and then we have our V2, which is known. Looking for the power in our current source right here, we know that power is equal to voltage times current, so we just have to find the voltage flowing through this current. To do this, we'll use the node voltage method. First, we need to define our node, and for here, we only have 2 nodes, so we're just going to use this one right here. Now we're going to actually use the node voltage method. This is just node 1, so we're basically going to fork off of this step. Looking at this, we can see that our first current is going in this way. Since it's going in this way, we're going to have our voltage 1 minus our source voltage, which is 20 volts. And this is all going to be over the 15 ohm resistor. The reason we have this is because our 15 ohm resistor and this part of our circuit right here are in series. And when they're in series, that means the voltage is different. So we're going to take our voltage 1 and subtract it from our voltage source, and whatever voltage is left over after going over our 15 ohm resistor will be right here. Next, we are going to look at this part that's going this way. However, instead of going this way, we're actually going to be going this way. This is the direction of our current. We don't need to do this part right here. This is to find the current, since we're already given the current to be 2 amps. So we're just going to add 2 amps right here. Lastly, we are going to do this last part. So we have our V1, which we don't know. So we're just going to have a plus V1 because the V1 from here is going out this way. And then we have a minus V2 because whatever voltage is left over from this 10 ohm resistor right here is going to be in our equation that we're writing out, in this part of the equation that we're writing out. So this is also going to be over our 10 ohm resistor. We know our V2 to be 25, so we're just going to replace this with 25. And this is all equal to 0. We have our equation with only one unknown, so we can just solve from here. What I'm going to do first is multiply everything by 150. And this is what we are going to get right here. I'm going to simplify a few things. First, our units. We know that voltage is equal to current times resistance. So if we have voltage over current, we get resistance. That means voltage over ohms is equal to amps. So I can get rid of this voltage and this ohms right here and turn this into an amp. I'm also going to do the same thing right here where we take the voltage and the resistance away and it becomes an amp. That way we can add all of our amps together and move it to the right side since they are constant. And then we're going to multiply everything by an ohm. That way we can get rid of these denominator ohms, and then we can add the V1s together. If we do this, we're going to get 25 V1 is equal to 875 amps times ohms. And from this formula right here, amps times ohms is just equal to a volt. So we can get rid of our amps times ohms and replace it with a volt. Then we are going to divide our 875 by 25, and this is going to give us 35 volts. So this is our voltage. Now we're going to plug it into our power formula right here. We have P is equal to 35 volts, and this is being multiplied our amps, which is 2 amps. Now, is this absorbed or delivered? Well, if we look at our circuit, our voltage for here is going this way. Our voltage for here is going this way, so we can say that we have a plus minus like this, and our voltage is going this way. We can see that it's in the opposite direction of our current. And since it's in the opposite direction of our current, that means we have to have a negative. Because if it's in the opposite direction, it means it's being delivered. So when we write out our answer, we're going to get that P is equal to negative 70 volts times amps, and volts times amps is just watts. So we have negative 70 as our answer. It's important to note that this is being delivered from our previous problem that looked like this. Linked below in a playlist with other problems, we had the voltage look like this, where we had a plus minus like this, and then we also had the current, which is going this way because it was not defined. Since these were in the same direction, we had the power being absorbed here, which is different from our current problem where the power is being delivered. But this is how you do this problem. Again, there are more videos linked below for help with homework or studying for exams. There's also notes for this subject and the entire circuit analysis in a Google Docs right below it.